All right, chapter 6, the normal distribution, and this is the second part. We looked at finding the area under the curve. If it was a body measurement, if it was a tail measurement, versus if it was mean and z. So now we're going to kind of go backwards. I'm going to give you now the area, and you got to match it to the corresponding z-score. So on the handout, number 1, it says obtain the z-score for the area under the normal standard curve to its left at 0.025. So first we got to distinguish what type of area did I give you. Did I give you a body or did I give you a tail? Now in these first 6 problems, we're just going to be looking at body and tail. We're not looking at mean and z, okay? So remember when we went over the types of shades, I mentioned to you guys that in order for it to be a body, it had to be greater than 50% shaded, which in decimal form would be 0.50, okay? And then in order for it to be a tail, it would be less than 50% shaded, or again, that would be less than 0.5. So when I give you a measurement like 0.025, obviously that would be a tail. That is a small decimal. So you need to make sure you can distinguish between a body number versus a tail number, okay? Now that we know that 0.025 is a tail, if you look at your table and you look at the measurements in the body column, the tail column, and mean and z, all of your area measurements have 4 decimal places. So you do know that we're looking for 0.0250 if you're looking for that fourth decimal. It's a 0. So you would simply just go down the tail column until you found the number 0.0250. Now, once you locate it, you would see that it would be at z-score 1.96. So for those that's still looking, go look for z-score 1.96. And then take your finger and go over to the tail column. You will see the measurement 0.0250. It matches it to the T. Okay. Now I have those bells drawn for your assistance on this determining if it's going to be a positive z-score or a negative z-score. Okay, so if I'm saying left, I have that measurement on the left side as a tail. So we do know that our mean would be in the middle. And so on the left side to the left would mean that that z-score, yes, is 1.96, but it would need to be a negative 1.96. And that would be the z-score that matches 0.0250 on the left side. That's what I'm looking for from these first 6 questions. Let's look at the second one. It says determine the z-score for which the area under the standard normal curve to its left is 0.01. So again, you do know that that would obviously be a tail measurement, okay? Now, if you want to write it with all of the numbers, you know the last 2 numbers would be zeros, okay? Because we are looking for 4 decimals. 4 numbers behind the decimal. So that would be 0.0100. So we would look down the tail column, and this time, give you a couple seconds to kind of glance. When you look down the tail column, you do not see that number directly, okay? You do not. I see the first 100, you could say, number, 100 number, will be, okay, so I see the first number that has point zero 0.01, like 100, is going to be at 102. And that's going to go with the z-score 2.32. Okay. So this is what you do. Okay. I'm looking for point zero 100. But the first number that comes in the 100 range is 0.0102. So it's like 102. You're going to look at where point zero 100 would fall in between. So if you look at 2.33, look at that actual measurement, and you will see that this is where point zero 100 would fall if it was on the table. It would need to be in between these two numbers. I need us to be in agreement. So what we're going to do is obviously have to go with the number that's closest to the measurement that I gave you. So if we look at the 102, it's two numbers of a difference, versus 99 is one number of a difference. So we're going to use 2.33 as the corresponding z-score for the measurement point zero 100. Okay, so what I'm doing, I wrote down where the measurement I'm asking for, point zero 100, where would it fall? Where would it be if it was listed on this table? And it would fall in between point zero 102 and point zero 0099. So we're going to pick the one that will be closest to point zero 100, which is point zero 0099. And that z-score is 2.33. So then we determine, all right, if this is a tail measurement and we're talking about 2.33 on the left, because that's the direction they gave us, then you know that 2.33 would need to be negative. So our z-score, the corresponding z-score for that measurement, would be negative 2.33. Okay, so obviously you know that all of the numbers we could come up with as a measurement would not be on this table. So we're going to be kind of looking at, okay, which number is closest to the area that I'm asking for. So let's look at the third one. It says find the z-score that has an area of 0.75 to its left under the standard normal curve. So we have 0.75, and that you should know is a body. Okay, that's bigger than 0.5. Okay, it's kind of like saying 75% of the bell is shaded. So that is obviously a body measurement. Now, if you need to see all four decimal places, you know it would be 00. Okay, so you're looking for 7,500. So you're going to take your table and you're going to look for 7,500, 0.7500 in the body column. We switching columns. We just left tail, now we in the body column. And so when I look on the table, the very first 75 number I see in the body is going to be 0.7517. And that goes with corresponding z-score 0.68. Okay, that's the very first one that I see. Now, if you were to look at the number before that at 0.67, his measurement is 0.7484. So you're looking at where this 7,500 would be in between, okay? So to help me locate it on the chart, the 7517 was the very first 75 number under the body column. So I just glanced up and said, okay, 7,500 would fall in between the 7486 and the 7517. And then we're going to do that whole, okay, who's the closest? So this one, 7486, is going to be 14 numbers of a difference versus the 7517 is 17 numbers of a difference. So we're going to go with 0.67 as the z-score because that measurement is closer than 0.68's measurement, okay? So that's the z-score that we're going to go with. Now, let's determine if we are dealing with a positive z-score or a negative z-score. Now, it says that the area is 0.75 to the left, okay, to its left. So that means the majority of the bale is shaded towards the left side. Now, this is a little different from tail. A body measurement, you remember, it has to cross the middle. Okay, the body has to cross the middle. So in order for me to cross over the middle and go 75% towards the left side, 75% shaded towards the left side, that would mean that the z-score had to be on the right side to begin with. I can't shade more than 50% and still stay on the left side. That doesn't make sense. So you gotta do you gotta start on the opposite of the direction they gave you. If they want the majority of this bale shaded towards the left, I had to begin on the right side in order to go to the left, 75%. So that means that our z-score would be positive 0.67. Okay. Number 4. Obtain the z-score that has an area of 0.80 to its left under the standard normal curve. So again, and now that's my cursive L, lowercase. I want y'all to think I spelled it wrong. Just left my loops off. So again, we know that 0.80 is definitely bigger than 0.5. So that's a body measurement, okay? It's a body measurement. So we're looking for that actual number, okay? So when I go and look on the table and I'm looking for where the 8,000s are, okay? Where do they start? Where do they start? And I see the first number I see is 0.8023. That's the first number for the 8,000s, okay? And that z-score goes with 0.85. That's his z-score. So if this is the number, it would definitely fall in between whatever 0.84's measurement is, which would be 0.7995, and 0.85's measurement, which would be 0.8023. And so we look and we see that 79.95 would be what, 5 off versus 80.23 is 23 numbers off. So the closest would be 0.7995, which that z-score is at 0.84. So we're going to look at, okay, if I need 80% shaded again towards the left, okay, These are very similar, number 3 and number 4. I need to go 80% to the left. I have to cross the middle for it to be a body. So that means I have to start on the right side. So 0.84 is on the right side of 0, which will make that a positive z-score. So we're going to use the z-score positive 0.84 to match our measurement of 0.80. Okay, number 5, obtain the z-score who has an area of 0.95 to its right. Okay, so again, we're looking at that 0.95 is bigger than 0.5. So we know that's definitely a body measurement. Okay, and the number we're looking for is 0.9500. Make sure you got your 2 zeros. So you're going to look under the body column, and the first 95 number I see has 9505 with it, and that's for z-score 0.65. Okay, so we know we're looking in between 1.64 and 1.65. 1.64's measurement is 0.9495. So 0.95 would be in between them if it was on the table. Now, if you look, 0.9495 will be what? 5 numbers of a difference. And then 9505 would also be 5 numbers of a difference. This time, you have equally the same distance from either measurement, okay? So this is a special situation. If this was to occur, what you're going to do is take the z-scores and find the average. You're going to take 1.64 and add it to 1.65 and divide it by 2. That's finding the average. And you can do this in your calculator, and that will give you 1.645. This is like the only time you really see z-scores where there's 3 numbers behind the decimal. That lets us know that's a special z-score. So don't round it. I need to see all 3 numbers because that lets us know that the area for this one was equally the same distance from both 1.64 and 1.65. Okay. So what you're going to do is you're going to find the average of your z-scores. Okay, that's what I ended up doing, is finding the average of my z-scores. Now, all right, so now let's determine, do we have a negative z-score or a positive z-score? Well, this time I need 95% shaded towards the right side, okay? So if I'm going to the right, that means almost all of this bell is shaded towards the right side. I had to begin on the left in order to shade 95% to the right. So your z-score will be a negative 1.645. So our z-score is negative 1.645. Okay. Number 6. Obtain a z-score that has an area of 0.70 to its right. Okay. And again, this is a body measurement. Body measurement. And we're looking for 7,000. Okay, 7,000. So when you look on your table, the first 7,000 number has 19 behind it. 7019. And that corresponding z-score is 0.53. Okay, so we're going to be looking at between 0.52 and 0.53. 0.52's measurement is 0.6985. So obviously our 7,000 would fall in between. So we would look at our difference. 0.6985 would be like a 15 number difference. And 7,019 is a 19 number difference. So we're obviously going to go with 0.6985's measurement because it will be closer. So we're looking at the z-score 0.52. And then when we determine if it's going to be a negative z-score or a positive z-score, well, it says that we're shading 70% of this to the right side. So in order to shade that much to the right, I had to begin on the left and go right. Okay, I had to start on the left side and actually go right. So 0.52 would be a negative z-score for this measurement. So our z-score is negative 0.52. All right, the next piece, 6.3, says working with normally distributed variables. Now, this is where our word problems kind of come into play, okay? How do we utilize this in real time, all right? So the first couple of examples that you'll see there on the handout are dealing with IQs. And it says that IQs have a normal mean of 100. And you do know that's the symbol for population mean. Have a mean of 100 and a standard deviation of 16. And I want to know the percentage of people who have IQs between 115 and 140. Okay, so we talked at the very beginning when I brought up when we first introduced chapter 6, is that your z-scores only go from -4 to +4. So I have to transform or translate or change all real numbers to match a corresponding z-score number in order to fit on the bell. So I'm going to give you that formula for finding a z-score, okay? And that formula is, in order to find a z-score, you're going to take whatever number you're trying to convert, we're going to let that be x, minus the mean, divided by the standard deviation, okay? So if we were trying to convert, in which we're going to have to convert 115 and 140, in order to find those corresponding z-scores, we would say 115 minus 100 divided by 16. And that would give us 15 over 16, which is 0.9375. Okay? Now, the rule of rounding, if you go by your table, your z-score column has 2 decimal places. Your areas, that's the body, the tail, mean, and z, they have 4 decimal places. So when we're dealing with z-scores, we're going to do 2 decimal places. So this would be 0.94. So the z-score for 115 would be represented as 0.94. Let's find the z-score for 140. 140 minus 100 divided by 16. You have 40 divided by 16, which gives you 2.5. And since we need two decimals, you know that would be 2.50. So 140 would represent 2.50. Now, I'm going to show you on the bell what I'm looking for. Okay. We know that the mean is always in the middle, and that's 0. We just found that 115 represented like 0.94. That would be kind of there. And 140 kind of represented 2.5. That would be there. I'm asking you for the percentage of people that would have IQs between these two numbers, which is the same as me asking you for the area of this shaded region. Okay? Now, what makes this a true word problem is that this blue shaded region is not directly on your table. Okay? This is not a body picture. This is not a tail picture. Now, don't get confused because none of this is shaded. Okay? So it's not a tail and it's not a direct portion between the mean, because the mean is here where this goal line is. And my blue doesn't come all the way up to that line, and my Z. So I'm going to have to do a little math to find that blue part, okay? Now, this is what I know. This is what I have on my table. I know that I can go onto the table and find this piece that's in green. This is like this hole, okay? I don't need this piece, but wouldn't that be mean and Z? Wouldn't that be a mean and Z picture for 0.94? Because that's the space from 0, which is where your mean is in the middle, up until the Z score of 0.94. I can go get that green piece. I also can go get the mean and Z for both pieces. Do you understand what I just did? I did that in red. I put stripes so you can see. I can go get from here to here also mean and Z measurement because 2.5 is a Z score. So I can go get his mean and Z measurement. But his mean and Z measurement is going to include this piece, what I need, and this piece in green, what I don't need. Keep in mind what I just said. That measurement all the way to 2.5 is going to include this piece, what I don't need, and this piece that I do need. So it makes sense to me that I can subtract the two pieces. I can go get the mean and Z for 2.5, and I can go get the mean and Z for 0.94. If I subtract 0.94 off of 2.5, I'll have the blue piece by itself. That's what we're going to do. This is an application problem. So we're looking at mean and Z measurements, but we got to do a little math. So we're going to look at 2.5's mean and Z measurement and 0.94's mean and Z measurement. 2.5's mean and Z measurement is 0.4938 and 0.94's mean and Z measurement is 0.3264. And I write this at the top that this is mean and Z measurements. Okay. And then I'm going to subtract the two measurements, okay? So 0.4938 minus 0.3264 would give me 0.1674. So what I have, and I'm going to write it down here so this will kind of hopefully make a little sense. I just went and found, now this is what you just told me, this green piece, I'm going to write it up here. His measurement is the 0.3264. The total from here to here is 0.4938. And so what you just found is 0.1764. Now that should make sense. These two pieces together add up to the 0.4938. So I kind of had to work backwards to get the 1674. Okay. Now that's the area measurement as a decimal. The question asks that you would give me the percentage of people. So all you would do is move the decimal two places, and that would be 16.74% have IQs between 115 and 140. That's what I was looking for. Okay. Let's look at another one. Let's look at number 2. It says we're using the same mean of 100 and standard deviation of 16. Determine the percentage of people who have IQs between 120 and 145. So the very first thing, we got to convert 120 and 145 to z-scores. So we're going to say 120 minus 100 divided by 16. So that would give us 20 divided by 16, which is 1.25. That's the z-score for 120. Find the z-score for 145. You have 145 minus 100 divided by 16. And we get 2.8125. And we know that the rule for z-scores is 2 decimal places. So that's going to give us 2.81. All right, on number 2, I don't know if I hit the pause button. So I don't know if you were listening to me or not. Let's see. I don't know if it recorded. But on number 2, you're going to find the percentage of people who have IQs between 120 and 145. So we're using the same mean of 100 and standard deviation of 16. So I converted 120 to a z-score. So that's 120 minus 100 divided by 16. That would give us 1.25 on the dot. Then I convert 145 to a z-score, which will give 145 minus 100 divided by 16. And that gives us 2.8125. So the rule says 2 decimal places for z-scores. So that's going to be 2.81. 2 will make the 1 stay at a 1. So 2.81 will be the corresponding z-score for 145. So now let's look at what we're looking for on the bell. Okay. So we found that 120's z-score would be 1.25 and 145 z-score would be 2.81. So I'm doing it in blue as well. I'm looking for this region here shaded. How many people are in this area? Okay, now and again, even though it's tapering in the tail, this is not shaded. So this is not a tail shade, okay? Want to make that clear. This is not a tail shade. We're going to use, just like we did on the last problem, we're going to get mean and z-scores, okay? Because I can find the total shade from 0 to 2.81. I can find that number. That's a mean and z, okay? And I also can find the piece that I don't need. All right, so on our table, the total mean and z-score would be for 2.81. 2.81 would be 0.4975. And that's including this green piece, which I don't even need it, and the blue piece. So I'm going to signify that by drawing my lines across both. That's both of those, okay? 0.4975. So if I go and find that green piece, which would be the mean and z at 1.25, at 1.25, that mean and z is 0.3944. And if I subtract that off of the total, that would give me what's left in blue. So that's what we're going to do. We're going to take 0.4975 and subtract 0.3944, and that would give us 0.1031. So this piece in blue would be 0.1031. So answering the question, we would simply say that 10.31% of the IQs fall between 120 and 145. All right, the next one, number 3, we're using the same mean of 100 and standard deviation of 16. And it says determine the percentage of people who have IQs between 100 and 130. So we're going to convert 100. Now I would hope that you would notice that 100 is the start of your mean. That's where your mean is. So you see that gives you 0. And 0 on top of any number is 0. So we're starting directly in the middle, okay? And so we're going to convert 130. And so we got 30 divided by 16 would give 1.875. And again, we're doing 2 decimals. So that would be 1.88. 5 makes the 7 round to an 8, 1.88. So these are our two z-scores. We're at 0 and 1.88. So 0 is where our mean, our middle, and that was also where we found that first number to hit was at 0. 0 and 1.88. 1.88 is the z-score for 130. So I'm asking for this piece. I want to know how many IQs would be in this shaded area. So this is directly a portion from mean and z. There's no piece that you don't need. You need that whole piece. And this is a mean and z shade. Y'all see that that's a direct mean and z shade. So we would go to 1.88 on our table, and 1.88, that measurement is 0.4699. So if I'm asking you about the percentage of people who have an IQ between 0.4699, that would be 46.99% have IQs between 100 and 130. All right, number 4. We're using the same mean of 100 and standard deviation of 16. Determine the percentage of people who have IQs that are less than 120. Okay, less than 120. So we have converted 120, but I'll show converting it to a z-score again. And that's just simply 20 divided by 16 is that 1.25. And so we know 0 will be our middle, and we're at 1.25. And so the question says less. I want to know less than 120. So if I'm going to go less, wouldn't that be shading it to the left side? And it didn't say when to stop. I didn't give you a between. If I go less, I'm going to keep going until I taper out. So do you see what type of shade I've created? Okay. This is a body. Does everyone see? I crossed over the middle and I kept going out through the tails. So this is a body shade. Okay. So we're going to go on our table at 1.25, and we're going to find the body measurement, which is 0.8944. And we're just going to convert it to that's a percent. 89.44% have IQs that are less than 120. Okay. Number 5. We're using that same mean of 100, standard deviation of 16. This time we want to know IQs that are greater than 140. So we're going to convert 140 to a Z, and it's already been converted, but I'm showing the conversion again, and we get 2.5, and we know that would be 2.50. And so, all right, so we have 0 in the middle, and 2.50 would be here. And so if it says greater than 2.50, wouldn't that be going to the right side of it? And I didn't say when to stop. So wouldn't that be all of that tail? Yep, that would be a tail shade. So we're going to go to 2.50 on our table. And we're going to look at the tail measurement, which is 0.0062. That would be the area, but if I ask for the percentage, that would be 0.62% have IQs greater than 140. Okay, I think we're going to switch up our narrative here. It says on number 6, as reported, the times of the finishers in the New York City 10K run are normally distributed with a mean of 61 minutes and a standard deviation of 9 minutes. Determine the percentage of finishers with times between 50 minutes and 70 minutes. So we definitely need to convert these to C's. So we would say 50 minus 61 divided by 9. And so 50 minus 61 would give us a negative 11 divided by 9 would give us a negative 1.222. My 2's are repeating. So we know that that 2 is going to stay a 2. So that's negative 1.22. Then we're going to convert 70 minus 61 divided by 9. So 70 minus 61 is 9, and 9 divided by 9 would give us 1. So these are our two z-scores. Okay, so we have our 0 in the middle for our mean, and we have negative 1.22, and then we have positive 1. So we're looking at this shade. Now, the blue piece that I need, if you look at it, I need the whole blue piece. But I can go find the mean and z measurement, and that would represent what I got over here in green. I need what's in blue now. But wouldn't that be the mean and z between for 1? I can go find that number. That number on our table would be 0.3413. And then I also can go find this portion, which I'm doing in red, which is a direct mean and z for 1.22. 1.22's mean and z, this part is 0.3888. So if I'm looking for what's in blue, that's from this point to this point, when I add those two numbers up, yes, that's exactly what we're going to do. We're getting that total, so we're going to add it up. 0.3888 plus 0.3413. When we add that up, we get 0.7301. So if we were doing the percentage, that would be 73.01% of the finishers finished between 50 and 70 minutes. And the last one, number 7, we're using the same mean of 61 and standard deviation of 9, but I'm wanting to know the percentage of finishers with times less than 75 minutes. So we're going to convert 75 to a z. So 75 minus 61 divided by 9 gives us 1 point, and my 5s are repeating. So this time you do know that 5 is going to make the other 5 become a 6. That's 1.56. All right. So at 1.56, if I'm saying less than that, then again, I'm going to the left. And I don't say when I'm stopping, so it's going to taper on out through the end. And that would be a body shade. So we would look at 1.56 on our table. We would look at 1.56 on our table, where body, and that would be 0.9406. 0.9406. So as a percentage, that would be 94.06% of the finishers finish less than 75 minutes. So this is our application problems, and we'll look more into the bell once we're back in class. So again, this is chapter 6 on normally distributed variables.